Hello. So I'm going to go ahead and show how to find which expressions are equivalent with our exponent rules. These exponent rules are still kind of new to us. And so I'm going to talk through what I'm thinking in my head and what those strategies are. There's lots of different ways to do these problems, lots of different strategies to pull from. And so I'll be kind of going over those um, as I talk these through. All right. So this is from a lesson a couple days ago. It says two of these are equivalent. Which expression is not equivalent? And I've actually already clicked which one it is. And I can tell right away this isn't equivalent because these are being added. And our exponent rules, when we're dealing with exponents, we're dealing with multiplication. So this would be 3 plus 3 plus 3 plus 3 plus 3. Let me add that up. 3, 6, 9, 12, 15. This would be 15. I could multiply this all out and see what I get. If I get 15, it'd be equivalent. I don't think I'm going to, though. So 3 times 3 is 9, times another 3 is 27. Gosh, I've already got more than 15. But I could keep multiplying. I'm going to do that on a calculator here for you to see. I can pull up the calculator. It looks like I'm in the way. I don't know how to move myself. There we go. All right. So I can go ahead and multiply this out. 3 times 3. And I've got 3 more of those. 3, 4, 5. 5 of them. Well, I can already see, since I just said that I have 5 of them, because I said 2, 3, 4, 5 of them, I can already see that it's equivalent to 3 to the power of 5, because that's how I would do this problem as well. So I just actually showed 2 strategies there. I can multiply it all the way out and see that this one is 243. And this is also, if I multiply it out, I get 243. But while trying to do that strategy, I saw that the expanded form of this one was 5 threes. And that's what this means. It means 5 threes multiplied together. All right, let's take a look at another one. All right, here we go. We're going to go. I'm sorry, it's a little slow because I have to keep changing to like a mouse and all of that kind of stuff. All right, let me move my face again off to the corner. So, challenge number 2, which are not equivalent. So it's not just about the answer. I want you to understand what strategy I'm using in my head, because it's not always the same strategy. We can pull from different strategies. So I'm saying this is not the one that's equivalent. It's already clicked. But let's look at why. What am I thinking in my head? Well, I see that this has 3 5s. I'm going to go ahead and write that as 3 to the 5th. And it has 4s. I'm sorry, it has 4s 3 times. I'm going to go ahead and multiply that as 4 to the 3rd. Well, we learned a rule that if you have different bases but the same exponent, you can multiply the bases 20 and keep the exponent the same, 20 to the power of 3. Hey, that's what this one is. So that tells me that by process of elimination, this is not equivalent. Another strategy that I could use would be to think about what this means and what this means. Okay, this has a 20 in the base. Let's see if I can make some 20s. Well, 5 times 4 is 20. Hey, look, I can do that again. 5 times 4 is 20. I can do that a third time. 5 times 4 is 20. So another way to write this would be that I've got 20 3 times. 1 time, 2 times, 3 times. And that, again, is the same as this one. So I just showed 2 strategies, rewriting this expanded form as exponents and using one of our rules, or rewriting from something we maybe would have learned in fourth or fifth grade, that we can change the order, and 4 times 5 gives me 20. And I could do that 3 times. All right. I think I'd like to do one more. If you're feeling pretty confident, you can pause it there and go do some practice problems. But if you want to see one more, this video is focusing on the strategies you would use to find equivalent uh, expressions with exponents. So we're going to look at one more. All right, this one here, I've already clicked 6 to the power of 2 as the one that's not equivalent, but let's look at why. So I'm just going to kind of scan these, and I'm looking at what they have in common and what they don't have in common. And what I'm seeing is this is the only one with a 6. So I'm thinking, well, can I make 6s? In that last problem, we made 20s. Can I make some 6s? Can I make 2 6s? 2 times 2. Let's try that. 2 times 2. Well, that's not 6. This would give me 4s. 2 times 2 would give me 4. And if I tried to do like 2 times 2 times 2, well, 2 times 2 is 4, and times another one is 8. So I don't see how I can make 6s out of this. If I added them, I could, but we're not adding. All right, so I don't see how I can make 6s. So, okay, that strategy is not going to work for me. So let me try a different strategy. Let me try expanding this one and see if the expanded form looks like this expanded form. All right, well, this means 3 2s. 2 times 2 times 2. But it says that I need to do that again. I need to do another 2 times 2 times 2. Hey, look, I expanded it out knowing what these mean, and it looks the same as this one here. I didn't even need to put those parentheses in there. I could have just had 6 2s all lined up. But what this is showing us is I have one grouping, like 2 to the power of 3, and I have another 2 to the power of 3. That's what those parentheses are showing us. But I could also call this 2 to the power of 6, couldn't I? Because I have 1, 2, 3, 4, 5, 6. Let me say that again. I could write this as 2 to the power of 6 because I have 1, 2, 3, 4, 5, 6 2s. That's another strategy. Let me do that over here. Let me write this as a single exponent. That's a lot of times how we phrase it, a single exponent. Well, you might remember the shortcut rule that if you have a power to a power outside of the parentheses, I keep my base the same and I multiply 3 times 2 to get 6. So look, I used a few different strategies here. I tried to make 6s. It didn't work. That one's not equivalent. And so I tried some other strategies. I expanded something. I simplified something. And I simplified even further to a single exponent. And multiple times along the way, I could see that those were equivalent. I want you to actually be able to do all of this so that you are kind of elastic and able to do different strategies. But even knowing just a few of the strategies, you could find which ones are equivalent. Okay, but we're going to ask you to rewrite things as single exponent quite often. Or, another strategy, I just thought of one. We could find the final number answer and compare if they give us the same value. So God, we have like so many strategies. Don't let that overwhelm you. Let that give you options, that there's more than one right way to do this problem. All right, thanks for sticking with me on this. And you can watch it as many times as you need to. Go do some practice problems.